Hello, class. This is a lecture on solving polynomial equations in factored form. This is section 8.4 in our textbook. To start section 8.4, we need to understand something called the zero product property. The zero product property is not particularly mind-blowing or anything like that, but what it allows us to do is super critical as we proceed in the rest of Algebra 1 and in Algebra 2. What the zero product property states is that if you have two numbers being multiplied, we're just going to call them A and B, and their product, when you multiply them, what you get is 0, then either A is 0 or B must be 0. Let's dive into this. If we have two numbers, okay, and I don't know what those two numbers are, but when you multiply them, you get 0, it has to be true that either this number here is 0 or this number here is 0. I'm always looking to retire, so if you can think of two numbers that when you multiply them together, you get 0 and neither of them are 0 in the first place, you let me know and we can be really rich. You have the idea, I'll write the paper, and we will be very rich, but please don't spend too much time on this because this doesn't exist, right? There is no such way that you multiply two numbers and you get 0 out where one of those two numbers doesn't equal 0 in the first place. So what does this mean for us? Well, we're going to have problems that essentially are A times B equals 0. Let's take a look at this example. We have something, and we're multiplying it by something else, right? X plus 3 times x minus 5, and it's equal to 0. In order for this to be true, either this must be 0 or this must be 0. So then we have to ask ourselves, what would make this first parenthesis 0? What number would you plug in for x that when you add 3 to it, you get 0? And if you're not sure, set it equal to 0 and solve for x. Subtract 3 to both sides, you get x is equal to -3. Hopefully you guys can vouch for this with me. If you plug in -3 and you add 3 to it, it gives you 0. You should be able to do this basically by looking at it though. What makes this one 0? That would be 5. So the answer to this question would be -3 and 5. Let's just verify this really quickly. If you plug 5 in to this one, you would get 8. And to this one, you would get 0. Well, what's 8 times 0? It does work. It does give you a 0. I could do the same thing with -3. If you plug -3 in for both x's, this top one would be 0, or this first one would be 0, and this one would be -8. And what is 0 times -8? 0. So -3 and 5 are your solutions there. Same idea with this question. You have A, and you're multiplying it by B, and you get 0. Then either A, this one here, must be 0, or B, this one here, must be 0. Well, what makes 3x plus 15 equal to 0? You might not know by looking at it. So set it equal to 0 and then solve for x. That'll tell you what you would plug in to have it be 0. Subtract 15 on both sides. Divide by 3. Answer. Do the same thing with this one here. What makes this one 0? That would be +4. If you didn't see it right away, you can set it equal to 0. You'd solve for x, add 4. Those are your two answers. That's hopefully pretty straightforward. Some of the problems might get a little bit more challenging here. Here we have an example where this is the A and this is the B. What makes the A 0? What would you plug into x to make it 0? Well, that would just be 0. And B, what would you plug in for this x to make it 0? That would be -3 halves. Why don't you guys try this one here? Here's one parenthesis. Here's the other parenthesis. What makes the first one 0? Well, set it equal to 0 and find out. What makes the second one 0? Set it equal to 0, find out. Here I'm adding 5 to both sides, so I'd have 2x is equal to 5, and then divide both sides by 2, that would be x is equal to 2.5. This example here, I'd subtract 8 to both sides, so I'd have 3x is equal to -8, and then x is equal to -8 thirds. Answer, 2.5. Answer, -8 thirds, or -2.67. I'm going to skip these examples, but go ahead and if you want to pause it here and get the answers, make sure you know how to do it. You would have gotten 2 there and negative 3/2 there, and negative 2/3 here, and 4/9 in this problem. There's another section to this lesson, and that deals with the greatest common factor. And so I want to review. This is prerequisite knowledge. This should be stuff that you already know. What does it mean to be a greatest common factor? So here we've got some numbers, 12 and 42. If I asked you to find out what the greatest common factor of 12 and 42 is, you should have no problem doing that because you used to do this in elementary school. But let's just kind of talk about it. Greatest common factor means the greatest factor they have in common. If you were to think about all the factors of 12, factors of 12 would be 1, 2, 3, 4, 6, and 12. The factors of 42 would be 1, 2, 3, 4 does not work, 5 does not work, 6 and 7, 6 comma 7, and 14, and 24, and 48. So if I were to ask you what is the greatest factor they have in common, you would look through your list and you'd say, well, the greatest factor they have in common would be 6, right? Because 12 is the biggest factor of 12, but it is not a factor of 42. The greatest one they have in common is 6 here. This is going to be important for you guys to be able to identify greatest common factors, but more than likely you're not going to want to list them out like this. So let's try to think about how to find a greatest common factor without making the whole list of all the factors. The first one here is going to be 4x and then 8. The factors of 4 are 1, 2, and 4, and the factors of 8 are 1, 2, 4, and 8. So actually 4 is the greatest common factor between 4x and 8. The x, how that comes to play is if they both have x as a factor, then you could consider that part of your factor. But 8 doesn't have any variable, and the 4 has an x. They don't have any variable in common, so I can't take that. I don't have a greatest common factor between them. Why don't you guys try to think about 6x and 15x? So first think about the coefficients, the numbers. What's the greatest common factor between 6 and 15? Hopefully you guys are landing on 3 as the greatest common factor between 6 and 15. This one has x as a factor, and so does 15. So actually the greatest common factor of 6x and 15x is 3x. And then lastly, the greatest common factor between these two would be 5x. The factors of 10x squared would be 1, 2, 5, and 10. And this one would be 1, 3, 5, and 15. This one has 2 x's, and this one has 1x. So in common, they have 1x. So what does this have to do with the beginning of this, the a times b equals 0 business? Well, we're getting there. If we can identify the greatest common factor between two numbers, we can use that greatest common factor to, in a sense, undo the distributive property. Remember, the distributive property says if you have something like 3 times x plus 2, you would distribute that 3 into the parentheses, and you would get 3x plus 6. That's the idea we're going to be using right here. So the greatest common factor between 3 and 42, hopefully you guys are getting good at this, is 3. So we can utilize the distributive property in essentially reverse. We can put it back into parentheses by taking out the common factor and writing it out in front of parentheses like this. So if 3 is a common factor between 3 and 42, the question you're asking yourself would be 3 times whatever goes here needs to give you 3. So 3 times what is 3? That would be 1. And then this 3 times whatever goes in this parentheses needs to give you 42. And 3 times 14 is 42. And this would be undoing the distributive property. And we could easily double check our work by saying, hey, what is 3 times 1? It's 3. And what is 3 times 14? It's 42. Okay, we got back to where we started. Let's try this with this one. What is common factor between 4 and 6? The greatest one happens to be 2. So if I take out a 2 and write it out in front of the parentheses, now the question becomes 2 times what is 4x? And 2 times 2x is 4x. And then 2 times what is 6? And that would be positive 3. That would be us undoing the distributive property. Greatest common factor between 6x and 15x. I believe we did this one over on this page. 6x and 15x, we got 3x. So that's the thing I'm going to factor out and put in front of the parentheses. And then the question becomes 3x times what is going to give me back to the question, back to 6x. And 3x times 2 would be 6x, right? Because 3 times 2 is 6, and the x doesn't have anything to combine with, so it's just 6x. And then 3x times what is 15x? That would be 5. Last one, the greatest common factor between 10x squared and 15x would be 5x. Remember, we're undoing the distributive property. The question we have to ask is 5x times what is 10x squared? And 5 times 2 would give you the 10, and x times x would give you the x squared. And then 5x times what is 15x? 5 times 3, 5x times 3 would be 15x. So this would be how we would undo the distributive property. I'm actually going to stop here for section 8.4. We are going to do more types of questions here in part B, but this will be it for section 8.4a. Please let me know if you have any questions.